Okay, so we're going to take a look at Objective 8 right now. We're still in Chapter 2. So this is Chapter 2, Objective 8, over how to read a chemical equation. And we're also going to look at enzymes as well. So there are three main parts, I suppose, to a chemical equation. That's going to be the reactants, the products, and the arrow between them. So the reactants are always going to be what goes into a chemical equation. So it's going to be the beginning. The reactants are always going to come before the arrow. The products are going to be what is formed in the chemical reaction. And the products are going to be what the arrow is pointing to. Now, the arrow means yield. If you want to think about it like an equal sign in a math equation, that's perfectly fine for what we're doing. For our purposes, this is the order that you're going to see. Now, yes, if you take a chemistry class, you can flip-flop that arrow all over the place. It doesn't always have to point in that direction. It could point the other direction, and that's fine. But for our purposes, it's going to be the reactants, the arrow pointing towards the products as you read the screen from left to right. Now, we have the basic water equation here. We have two hydrogen atoms combining with, that's what the plus sign is, one oxygen atom, or one oxygen molecule, I could say, two hydrogen molecules and one oxygen molecule, producing, remember there's that arrow there, two water molecules. So how am I going to ask the question on the test? I might say hydrogen is on what side of the equation? And I'll give you a chemical equation. It's not going to be the water equation, but I'll give you a chemical equation. And you just say, okay, well, there's hydrogen. It's on the reactant side. Answer is the reactants. I could say, and you're like, but wait a minute, hydrogen's on the other side. No, it's called water and on the other side. Okay, I'm not going to ask you about the hydrogen atom. So it would be water is on what side of the chemical equation? And then you would say products. That's how that question is going to be asked on the test. Now, these big numbers, I said we had two hydrogen molecules. We have one oxygen molecule. Remember, it's understood. You don't usually write ones in chemistry. So there's an imaginary one there in front of that oxygen molecule. And you have two water molecules that are produced. So these big numbers out in front of the chemical formulas, those are called coefficients. And it just tells you how many of everything you have. So again, the question on the test could be, how many water molecules do you have? Well, you have two. How many hydrogen molecules do you have? You have two. So I'll give you a second to take a look at question 23. Okay, so that should give you an idea about what to expect on the test. Again, anybody happen to know what equation this is? Well, if you said the cellular respiration equation that takes place in the mitochondria making ATP, you would be correct. You're going to see that equation again. Now let's take a look at enzymes. So maybe you've heard that enzymes speed up chemical reactions. And in a sense, that's true, but there's a little bit more to it than that. So an enzyme, hopefully you remember from the macromolecule discussion in chapter, I don't even know, chapter 1, I guess, when we talked about we're talking about macromolecules in this chapter, I'm sorry. So in Objective 11, you're going to talk about proteins. And an example of a protein that we're going to look at in Objective 11 in Chapter 2 are enzymes. Enzymes are a special type of protein. They're very particular, too, by the way. Their job is to speed up chemical reactions. Another characteristic of enzymes is they are not consumed in the chemical reactions, so you can use them over and over and over again. Let's take a look at this image here so you can kind of see what it is we're looking at. A plus B. A plus B is representing the reactants in this chemical equation. So you can kind of look at this chemical equation, which I should have written for you all, but I didn't. A plus B produces AB. So A plus B is the reactant. AB down here, that is the product. Okay? Now, with our reactants, you've got two situations here. You have the red line that you can follow, and this is the line without any enzyme involved. And then you have the blue line, which you can see is with an enzyme. So what do you notice right away? Well, I mean, we're still producing the products, sure, but with the enzyme, look at how much time it takes to actually start making those products versus the amount of time it takes to actually make the products without an enzyme. So time is going along the x-axis here, so that's time with an enzyme. This is time, I'm going to this X right here. That's time without the enzyme. So you can see it takes longer to actually make products if you don't have an enzyme involved. The other thing that I want you to notice is the height of the reaction without an enzyme versus the height of the reaction with an enzyme. Now, over here on the y-axis, we're looking at energy. So you can see that a non-enzymatic reaction, the red line, requires more energy than the reaction with an enzyme. With an enzyme, the peak doesn't go as high, so it doesn't require as much energy. So again, we're looking over here. That's the amount of energy with a non-enzymatic, with an enzymatic reaction. And then this is how much energy without an enzyme. So you can see without an enzyme, the reaction is going to need more energy to proceed, to actually form the products. That energy is called activation energy. So you can see here the pink line. I'll do this in red. I don't have pink. The pink line right here, this is the activation energy without an enzyme. And you can see the height of that arrow. Why am I starting down here? Because that's where the amount of energy was initially for the reactants. And then you can see the blue line, which again, we're still starting at the same place, but you don't need as much activation energy. So this is the amount of energy needed with an enzyme. So in order to get the reaction started, if you have an enzyme, it doesn't take as much energy to get the reaction started. So activation energy is decreased when an enzyme is involved. So some characteristics about enzymes. 3 things. They speed up chemical reactions. They lower the activation energy, and they are not consumed in a chemical reaction, meaning you can use this enzyme over and over and over again, because once it creates the product, if you look at the active site, which is this area right here, it looks the same. It didn't change. So you can keep reusing that enzyme over and over and over again. So question 24. Which one is not a characteristic? So it is able to be reused over and over again? Nope, that's a characteristic. That's a true statement. Speeds up a chemical reaction? Nope, that's a true statement. Raises activation energy? No, it lowers activation energy. So that's not an example of a characteristic of an enzyme. Is a type of protein? Yes, it is a type of protein. So your answer here would be C. And that's all of objective 8.